Dobre rano. Good morning, everyone. So my name's Nicholas Skoll. So this will be in English. I apologize for this, but this will be in English. So I am from EXFO. Thank you for inviting me here, Jan, Pavel. Thank you for your support. It's good to be here. Thank you. So my presentation is going to be on AI and the impact that's having on the optical networking industry. And I'll talk about the global situation and then try and think how that's going to impact us in Europe, in Central Europe, okay? So just EXFO, I think you're familiar with EXFO. So the company has been around for more than 30 years. It's an engineering company, so we have lots of people in R&D, we have patents, we have 2,000 people around the world. So it is an engineering company, EXFO, involved in test and measurement. So there's 3 parts to the presentation. So the first is to talk about the global impact of AI. And really, it's about the money. Money, 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 okay? Money, 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 money. Because then that helps us think about the impact on technology and adoption. So the second part is then to talk about the data center infrastructure. So it's infrastructure. And then the third one is Europe, impact on Europe. So start with money. We're going to start with money. So the data center capex for 2026 is $650 billion. So a huge amount of money, $650 billion is going to be spent by 5 companies. 5 companies, incredible amount of money. So it's AWS, Google, Meta, Microsoft, and Oracle are the 5 companies that have committed $650 billion of their own money. So this is straight out of their own pocket. It's not financed by external banks. This is out of their profits. $650 billion in 2026. And you'll see the market cap of these companies is actually going down because of that investment, because the market is worried about the amount of money they're committing for data center infrastructure due to AI. So $650 billion, 5 companies, and it's mainly been spent with one company, which is called NVIDIA. So that's $650 billion, mostly is going to one company, NVIDIA. And 5 years ago, NVIDIA were worth $150 million, $850 billion market cap in 2020. Now it's the largest company on the planet at $4.5 trillion. So in 5 years, they've gone from small to huge company, the largest company on the planet, NVIDIA. Okay, so this is the big picture. So how is that impacting us? Okay, so what? How's that impacting us? And the optical networking industry, which is the industry we're working in. Okay. So there's been 3 announcements in the past few weeks, which are big announcements. So Meta have committed to spend $6 billion on fiber optic cabling and connectivity to Corning. $6 billion order for cables, which is massive, massive impact. It's more than what they are generating in the past. It's their biggest order by a long distance, huge amounts, and they're now having to build up their production to meet the demand from one customer, Meta, $6 billion. NVIDIA are investing in product research a product development, and they've committed $2 billion to two companies, Lumentum and a Coherent. These are now huge orders that is having a direct impact on the optical networking industry, but it's from that $650 billion investment from AI. So this is the big picture that's happening globally. And the infrastructure, so before 2020 was the dividing line of cloud versus AI. So before 2020, so the data center infrastructure was big in terms of investment in cabling and optics, but there was a big transition after 2020 due to the transformation of AI networks. And the major difference between cloud and AI is AI servers so connect at a much higher data rate. So they're connecting at 400 gigabit at the server, whereas cloud is around 10 gigabit. So this is a huge difference in the amount of data that needs to be transmitted around the network. And AI is like a brain. It's a neural network. So it's a brain of smaller units that is then networked to create a bigger computer, a supercomputer. So all of the data has to be transmitted around the network at a 1-to-1 ratio. So this is the big difference. With cloud, you could have more traffic at the server, and you can have a smaller amount of traffic that leaves that switch. So the infrastructure can be smaller, whereas AI is a 1-to-1 ratio. Whatever goes into the switch has to come back out. So that means lots more optics and lots more fiber. There's a 4x increase in fiber, which is why you're seeing these big orders now on Corning, this $6 billion order. So there's a big difference between cloud and AI networks and the consumption of optics and fiber. Okay, so that was the money. So there's lots of money that's coming in from these big companies, and it's having an impact now on the optical manufacturers and their roadmaps and their product innovation. So now I'll talk about the impact on the data center infrastructure. I'm going to use photography, so it'd be nice and easy to see what's happening, the physical infrastructure. And so the example I use is a company called xAI, which is Elon Musk's company. So Elon Musk founded xAI in December 23. And he purchased a site, which was Electrolux manufacturing site in Memphis, Tennessee. He's purchased this site and he's turned it into a data center. So it's been about 2 years now from the start to now. It's been about 2 years. And he's building an AI called Grok. And so Grok is going to be the AI that he merges with SpaceX for his space exploration. This is his plan. He's spending $1 billion per month. So they're burning through $1 billion per month on the compute assets, on GPUs, on all of the switching infrastructure, and training. So he's burning through $1 billion a month in building this AI. Huge amount of money. And so this is what the site looks like. All right, so it's in Memphis, Tennessee. It's currently consuming about 1 gigawatt of power per hour, which is enough to power about 500,000 homes. So very, very power hungry on the electrical infrastructure. He's bringing in power from Mississippi and Tennessee, has a substation. He has all of his battery packs for stability. So the power is charging the battery packs, and the battery packs can then provide a stability to the compute network. But it's enough to power 500,000 homes, this data center. And he's building more and more compute here. Huge facility. So this is what it looks like inside. So there's 200,000 GPUs online at the moment that's training Grok, his AI. And there's about 3,000 racks. Each rack is worth about $3 million. So this is where that $650 billion, this is how it rolls down. Each rack is worth about $3 million. There's about 3,000 racks for the 200,000 GPUs online as training Grok right now. And in his phase 2, which will come online later this year, there's 550,000 GPUs. So huge, expensive facility that's training this AI Grok. So this is what the server looks like. So on the racks, there's 6 servers. Each one has 8 GPUs. And each server, so this is the network interface card that feeds the GPUs. And the transceivers are 400 gig. So high-speed transceivers, 400 gig at the server. So they're using our network testers for the transceivers, because these transceivers are expensive. So they don't want to just dispose of them. They want to test them first. So they're using our network tester for this purpose. So the transceiver, if you've seen these, it's in the QSFP form factor. It's 100 gig per optical lane. So there's 4 fibers in one direction and 4 fibers in the opposite direction, transmit and receive. So there's 8 fibers in total. And it's on the MPO8 connector, which is angled because of the sensitivity of 400 gig, the reflections and the sensitivity of that receiver. So they're approximately $1,500. They're expensive, and there is millions of them inside that building. So this is the switch, the first switch. So that was the server, and it connects to the first switch. And so this is the 1-to-1 ratio for AI. Very clear picture. You can see the multi-mode cable goes into the switch, 1/2, and then it leaves the switch on single mode. So this is the 1-to-1 ratio of AI for these neural networks. So it's 400 gigabit everywhere through the whole fabric. This is a 51.2 terabit switch. So monster, 51.2 terabit switch, has 64 ports of 800 gig. Each transceiver is divided into 2 400 gig circuits. You can see 2 MPO cables coming out the transceiver. And so that's connecting to the server, the server racks. And so this is the fiber inspection scope. So they're inspecting the fiber connector. So the transceivers, the loss budget on a transceiver is very small. It's like 1.5 dB. So keeping things clean is important. So the MPO connector, it looks like this. So there'll be 8 fibers. And so the image on the tester, we can see all of the fibers, and if there's one that's failed, then they can find the failure and clean it. So they're using the inspection scope to make sure that everything is clean, and so the system works, right? Everything needs to be clean for the system to work. It's AI, everything's talking simultaneously, so if you have a failure of one link, it brings down the performance of the whole neural network. So the cost of these cables are in the thousands of dollars, and they look like this. All right, so this is the fiber in the trays. Incredible. And they're high-density pre-terminated cables. Each cable has thousands of fibers in, and there's many cables. Each rack requires about 800 fibers. So a huge amount of fiber. So this is the $6 billion order on Corning. Now you start to see where the money's coming from. And so there's a potential for some multicore that Jan spoke about. So this is a great application for multicore because the weight in the trays is heavy. So multicore could be a 4x decrease in the amount of cables and weight. So they're using our PXM LXM. So this is a multi-fiber optical loss test set for measuring insertion loss, length, and polarity, making sure the fibers map properly. On the single mode as well as the multi-mode, so they're testing, every single cable gets tested after it's installed because of the dependence and because it's critical infrastructure for AI. So they're making sure everything is tested, inspected, and cleaned before they switch on the network.
Sure. The slide back. Kdybyste chtěli vidět tohle zařízení, vysílač, přijímač, dokážete paralelně měřit 12 vláken, 24 vláken a víc. Je to vloženě dělaný na multifibery, jak single-modový, tak multimodový. Tak je tady vystavený hnedka, má ho tam Pepa Beran, hnedka vedle stánku Optical Cables, hnedka na tom prvním stole.
Okay, so this is the spine switch. So you saw the first switch was multi-mode in, single mode out. So this is the next switch. That's single mode and then goes back down. But you can see it is very dense, right? So you can see the density of these networks. And there's an opportunity for co-package optics. So that is a new technology that will come into this application. Co-package optics reduces the power consumption because there's many transceivers, power is a limitation. So co-package optics is a solution for this problem, the power consumption of all of the transceivers. Okay, so that was XAI. So this is now in Europe. I'm trying to come back to Europe now. So there's a company called CoreWeave, and this is an AI company that sells AI compute as a service. It's an American company. But they have infrastructure here in Europe. They started to build in Europe. There's a facility in Norway. And so what I showed from XAI is now old technology because the product innovation cycles are very quick in this industry. So what I showed you was old technology. And the new technology from NVIDIA is what CoreWeave are using. The new technology from NVIDIA is what CoreWeave are using in this facility. Okay, so this is the GB300 NVL72, so it's their blueprint rack design. So this has 72 GPUs and 36 DP, so it's about 1,000 fibers connect this rack. Just to give you perspective, about 1,000 fibers connect this rack. And the next rack from NVIDIA that will come out next year could have about 10,000 fibers connecting it. Just so you can start thinking about the next cycle of technology. This is about 1,000 fibers per rack. Next year, it could go up to 10,000 fibers per rack. 576 GPUs, 1.6 terabit, 16 fibers per transceiver. So fiber, there's big business for fiber. Okay. So the impact on Europe, so the outlook for Europe, and I'm trying to think about the outlook for Europe because I've spent a lot of time in the States, in the US over the past few years, looking and following this industry. But I'm based here in the UK and I'm European, so my attention is going to be on Europe for the next few years. And I'm trying to think about the impact of everything that's happening and so what that means for us in Europe. So this is a picture of the data centers in Central and Eastern Europe. Completely different to the US, completely different to the US. There's about 3,000 data centers in the US. Huge, huge, huge facilities too. In Europe, it's much smaller. Same in UK, it's much smaller. In Czech, according to this company, there's 55 data centers. And they will be older facilities, but there's only 55 data centers. The EU is heavily regulated as well, so it's more difficult to make investments in data centers inside the EU. So I think that the investment is going to be in interconnects first, because we will consume the compute from other countries, same in UK, but there needs to be some build out of infrastructure in Czech, maybe not for creation or possibly for creation, but certainly for caching and providing the content to the users. As you build out the FTTH and you consume AI, there has to be an infrastructure, a local infrastructure, to support that AI that we consume. And everyone, I'm sure, has already started to use ChatGPT and some of these AIs. So this is going to need to be supported by infrastructure here in the Czech Republic. So I expect there'll be a build out of data centers, but also interconnects. I think it's going to be more about interconnecting all of the facilities within Czech to the wider Central Europe. Rata, any thoughts here? And I'm only thinking here, so I don't know, but any thoughts?
I think biggest opportunity which I největší možnost, kterou vidím, je právě ten data center interconnect. Proto si taky myslím, že se připravují projekty v zahraničí, který projektují síť, která má přeběhnout Českou republiku a která je postavená na holokorech. Druhá věc, pokud se podíváte na každý to datacentrum a pokud máte v reku 800 nebo 1000 vláken podle toho, kterou generaci NVIDIA máte, tak těch 1000 vláken musí někdo nainstalovat a musí je taky změřit. A pak je velký rozdíl, zdali to změříte za den, anebo jestli to změříte za měsíc, když máte špatný měřáky. Takže v tomhle vidím ty největší opportunity. A další věc, jediný datacentrum, který vidím teďka v celém regionu. Tohle je docela scary obrázek, protože když se ho pustíte se všema ostatníma datacentrama, který jsou v Evropě, anebo když si dáte ten světovej, tak ta východní Evropa vypadá opravdu nejbídněji z celého toho světa. Pokud se nedívám na Rusko a podobně. A myslím si, že to souvisí s cenou energií, protože každý to datacentrum je ohromná spotřeba energie, kterou potřebujete na chlazení. A druhá věc, potřebujete toho, kdo to zaplatí. A to tady v té východní Evropě příliš nevidím. Jinak ty multikory se vyrábějí v Polsku. Ty multikorové breakouty pro všechny ty datacentra se vyrábějí v Polsku.
Yes, so Ratas, and maybe you can comment on this. This is the last slide and then it's a takeaway. So this is just showing the products for the Metro Core network.
Pokud se podíváte, tohle byl popis jedné aplikace. Pro EXFO jako dodavatele měřící technologie to byl jeden z největších biznisů, který jsme v loňském roce udělali. Jsou to stovky měřáků, které jsou na 400 giga, 88 480, pár jich je tady v České republice. FIP 500, základní nástroj, který máte v těchto aplikacích, je Video Inspection Probe. 500 je tak univerzální, má tak velký effective field of view, že ji dokážete použít prakticky na jakýmkoliv typu multifiber konektoru a dokážete ji použít i na nových konektorech, který mají v sobě multikorový vlákna. To znamená, kromě toho, že uvidíte jedno vlákno, tak uvidíte i ty 4 kóry a budete schopni vyhodnotit, jak ty jednotlivý kóry s tím pinem, který vám vlastně udává polohu toho konektoru, v jakém jsou stavu. Další věc, spektrální analyzátory. Proč spektrák může být důležitý? Souvisí to s hollow corema. Hollow core v tu chvíli, kdy absorbuje vzduch při svařování nebo spojování těch vláken, tak ten vzduch vevnitř působí ve své podstatě jako filtr. To znamená, že vám určitý spektrální čáry lehce vyfiltruje. Teď je otázka, jestli je to důležitý nebo ne, je dobrý na to mít ten spektrák. Druhá věc, proč používat spektrák, jsou tam CDC switche, který můžou být nějakým způsobem spektrálně závislý, pak jediný tool, kterým to můžete testovat, je spektrální analyzátor. A to další, to souvisí s velkým počtem měřených vláken. Přichází nový měřák, jmenuje se 975 FTB, pokud je to modul, nebo FTB Lite, pokud je to celý měřák, který umí měřit vložný útlum odrazu přímou metodou a reflektometrem na jednom portu, kde tím portem je 24-portový MPOčko. Ve své podstatě to znamená, že změříte 24 portů během nějaký necelý minuty. Zase aplikace na tyhle datacentra, kde jsou velký počty vláken. Je to o čase, který strávíte s měřením.
Okay.
Anything else?
Yeah, that's it. Okay. So just the summary then. So the AI investment is going to reach some more than $650 billion this year. So that's having an impact on optical technologies. All these companies are now innovating with new products and solutions. You're going to see this from us and many other companies. And so Europe has to follow and upgrade their networks. That has to happen. I'm not sure what it's going to look like, but that has to follow as Europe has to upgrade their networks. Thanks for listening to me. I appreciate it. Thank you very much. Enjoy the rest of the seminar.
Yeah. Takže i my děkujeme Nikolasovi. Tady ta přednáška, možná vám to připadá, že to je vzdálený, nebo že to je tak nedotknutelná technologie. Ono se týká datacenter a nebo potom páteřních tras, ale on ten upgrade přijde velmi rychle. Ten svět ICT se opravdu vyvíjí dynamicky a vyvíjí se spontánně a je to o těch aplikacích. A viděli jste, že ty investice do třeba těch 5 největších firm celosvětově, takže tečou spontánně, na to nejsou žádné eurofondy, to prostě jsou peníze, které ten investor do toho dá, protože se mu to vrací, ten biznis přes datacentra. Uvidíme, kdy ta vlna přijde do České republiky a na Slovensko, ale ono to potom bude hodně rychlý. Ale to, co zatím teďka, to, co můžete cítit, a proto jsme to zařadili i tady do toho semináře, tak je to, že jak se instalují optická vlákna a kabely v přístupové síti, tak je možné, že to, co je součástí té primární sítě na optiku, tak najednou paralelně vedle v té samé chráničce anebo i v tom samém kabelu část vláken je použitá jako interconnect mezi datacentry na vzdálenosti do 10, do 40 kilometrů, prostě v rámci metropolitní sítě. A pak máte úplně jiné požadavky na montáž té kvality. To není jako když připojujete rezidenčního zákazníka nějakou babičku, která jí tam jedno, jestli ten internet pořádně funguje nebo nefunguje. Tady opravdu ty vlákna musí mít ty parametry. Takže ono to bude poměrně rychlé a už teďka se můžete setkat s tím, že v přístupové síti máte jiné požadavky na montáž nebo na měření vláken, když to je vlákno pro FTTX pro rezidenčního zákazníka, anebo když to je vlákno pro propojení datacenter. A to může být vlákno v tom samém kabelu. Sorry, Nicholas, it was the introduction. Not at all. So, is there any question? Je nějaký dotaz? Tady ano, Petr Koudelka, dáme mikrofon. Dej mikrofon, Vráťo, prosím. Není zapnutý asi ještě. No.
Jak se tyhle vlákna chovají z hlediska disperzí?
Question is, what are the dispersion behaviors or features of hollow-core fibers or multicore fibers?
Rata, do you want to take this one?
V každém případě multikorový vlákna jsou velmi podobný, to jsou klasický G652 ve své podstatě, to znamená měření disperzí je jeden z parametrů. Docela zajímavý u těch multikorů je měření crosstalku, který některé firmy požadují a je to z důvodu, pokud je to pro quantum key distribution, tak se musí trochu vytunit ta síť z hlediska crosstalku, vybírají se vlnové dílky. Co se týče hollow-coreu, taky se na nich měřily disperze, ale jsou ultra nízký. Chromatická disperze, ta se ve své podstatě, ta je ovlivněná to, jaká architektura těch kapilár v tom vlákně je a ve své podstatě nikoho nezajímá, protože to DSPčko velice dobře vykompenzuje. Co se týče PMDčka, to se měří, ale to, co jsem viděl, tak bylo velmi malý. To, co jsem viděl na starých vláknech, který používali photonic bandgap, tak tam disperze byla relativně mizerná. PMDčko, myslím.
Pro tyhle vysoké rychlosti už se řešila i profilová disperze. Tady se taky řeší?
Řeší.
Tak. Děkujeme, slyšeli jsme odpověď řeší. Pepa Beran by rád něco doplnil.
Já jsem chtěl jenom v návaznosti na tu přednášku od Nikolase vás pozvat k nám na výstavku, protože tam máte možnost vidět nejenom tu přímou metodu, která vám během 1 vteřiny oměří všech těch 12 vláken v tom jednom kabelu, ale stejně tak tam jsou i ty měřáky na 400 giga, 800 giga a můžete se tam podívat, jak vypadá spektrum v návaznosti na to, jakýho konkrétního typu je to 400 giga nebo 800 giga, takže neváhejte, přijďte se podívat, ať už teďko během přestávky, nebo potom kdykoliv později k nám na stánek. Rád vám to tam předvedu a případně pohovořím na toto i jiná témata. A potom úplně na závěr jsem vás chtěl pozvat i na konferenci Kablex, která bude v květnu a já tam budu mít příspěvek o právě těch vláknech, o kterých tady bylo hovořeno, to znamená multicore, hollow-core a tak dále.
Jak jsem říkal, ty PXM, LXM měřáky jsou v nové generaci 24-portové, tohle je druhá generace, která je do 12 portů, kde vyměňujete typ toho konektoru, může to měřit duplexní LCčka nebo single vláknový aplikace nebo do 12. Teď ten samý měřák může být do 24, to znamená univerzální na jakoukoliv architekturu nebo na jakýkoliv multifiber konektor. Pokud všechno dobře půjde, tak na Kablexu budeme ukazovat ty 975, který umějí ukázat i mapování v rámci toho multifiberu. Je ve své podstatě jedno, jak máte překřížený vlákna, nakreslí vám mapu těch vláken, jak vypadají v celé té kabeláži.